Dear learners, today I am going to take a unit which is entitled Propositional Logic and Predicate Logic. This unit belongs to the first semester Logic 1 paper, and the number of this unit is Unit 11. So today's class you will be able to know what is Propositional Logic and what is Predicate Logic. We will also study the simple statement from the foundation of the language of Propositional Logic. Now, so far as the branches of Symbolic Logic is concerned, you will find that Symbolic Logic is something. We'll just give a simple briefing regarding it. You'll know that in the history of Western logic, Symbolic Logic is relatively recent so far as the Aristotelian logic. Aristotelian logic is the old form of logic, but Symbolic Logic, which is again another name of Symbolic Logic, is Mathematical Logic, which can also be called as Formal Logic or Modern Logic or Algebra of Logic or Logistic. That means if we'll say Mathematical Logic, it will mean Symbolic Logic, or Formal Logic will also imply Symbolic Logic, Modern Logic, or Algebra of Logic or Logistic will also imply Symbolic Logic. Now, Symbolic Logic has different types of branches. They are Predicate Logic, Propositional Logic, and Logic of Classes. In this unit, you will be able to know about Propositional Logic and Predicate Logic. Now, what is Propositional Logic? Propositional Logic is the logic of propositions. It considers simple statement as its atomic or the most basic or elementary units. The logic assumes simple proposition as individual units. On the other hand, whenever you will discuss about predicate logic or will have to know about predicate logic, will know that it is the logic of predicates or properties and things or objects to which the predicates may be ascribed. This kind of logic deals with the internal structure of both simple and compound proposition. I think all of you know what is simple and compound proposition. Predicate logic deals with these two kinds of proposition. Now, first we'll know what is propositional logic. If we are going to discuss about propositional logic, first of all we'll have to know that propositional logic is that branch of symbolic logic which considers simple statements as its atomic or the most basic units. That means propositional logic mainly deals with simple statements. Again, propositional logic studies ways of combining or altering statements or propositions to form more complicated statements or proposition. That means from different simple proposition, with the help of propositional logic, we can combine or we can make a complicated statements. Another name of propositional logics are sentential logic, sentential calculus, or statement logic. Sometimes it has also been called propositional calculus by those who are keen to emphasize the analogy of mathematical calculus. So far as propositional logic is concerned, propositional logic is always deals with statements. It considers simple statement as its atomic or the most basic or elementary units. Again, so far as propositional logic is concerned, we will know that it assumes that simple propositions are individual units. That is what I want to say is that in this kind of logic, that means in propositional logic, simple propositions are not further analyzable. We cannot analyze simple proposition. Thus, propositional logic does not deal with the internal structure of the substructures of simple logic. That means whether that particular statement is or that particular simple statement is true or false, it is not dealt by propositional logic. It will only see the structure of propositional. It will only see the structure of that particular statement, whether that particular proposition is correct or not, true or false. Again, the simple proposition form the foundation of the logic of propositional logic. Compound propositions are formed by combining the simple proposition with the help of connectives. This particular thing I have already discussed in the unit 6 and 7. You will be so in this today's lecture I am not going to deal with, but you will only you just know it or try to you just make it clear that so far as propositional logic is concerned, in propositional logic, it deals with only simple statements and compound. So far as compound statements are concerned, compound statements are made by combining two simple statements with the help of connectives. Now, what are the connectives? Okay, propositional logic can be taught of as a primarily the study of the sentential connectives or logical operators. A logical operator is in any words or phrase used either to modify one statement or to make a different statement or to join multiple statements together to form a more complicated statement. Okay, in English, words such as and, that or, not, if, then, this particular words or group of words are used to make connect between two particular simple statements. Now, because and necessarily, okay, because and necessarily, these two terms are all used as operators. They are not used as connectives, but they are used as operators. Okay, so we'll find that, therefore, what mentoring that in a propositional logic, two kinds of symbol necessary, namely logical constant or logical operators, and secondly, we'll find that so far as in propositional logic is concerned, we'll find that again we use propositional variables which are also necessary to combine two simple statements or propositions. So far as propositional logic is concerned, we'll find that it studies ways of modifying statements such as addition of the words not. Okay, so far as addition of the word not, that is used to change the alternative statements into a negative statements. If it is a positive statement, it will become negative statements. Again, in propositional logic, you will find that propositional logic studies the ways of joining propositions to form more complex propositions or statements, as well as the logical relationships and properties that are derived from the methods of combining or altering statements. Propositional logic has its own symbolization keys or procedure. It will not use any symbol. Some particular kinds of symbols are used in propositional logic. In this procedure, each simple statements that is to be replaced by the chosen capital letters, and hence a unique capital letter for each distinct simple statements has to be selected. Okay, suppose one particular statement is symbolized with the help of one particular letter, one particular capital letter, then for the another statement we'll have to take one another capital letter of a English alphabet. Secondly, logical connectives is to be replaced by its respective symbols. Okay, we cannot use any symbols. By its respective symbols only we'll be able to replace those particular connectives with the connectives. For example, the conjunctive function. The conjunctive function, that means and. Okay, whenever we use and, it is called conjunctive function. If I'll just give you an example of conjunctive function, how we use it. Suppose we take a statement that is Radhakrishnan is a philosopher and Rabindranath Tagore is a poet. So we'll find that there are two simple statements here. One is Radhakrishnan is a philosopher and another is Rabindranath Tagore is a poet. But we'll have to make these two statements, we'll have to convert this we'll have to connect these two statements, and we'll have to make a compound statement. Now how we'll do this? Then we'll have to use the connective and. Now if we symbolize the term the statement or the proposition Radhakrishnan is a philosopher, we can use the word R for Radhakrishnan. Again, we can use the word Tagore, T for Rabindranath Tagore. So if we take Radhakrishnan is a philosopher as R, and if we symbolize Rabindranath Tagore is a poet to be T, then we can connect it with the help of R dot. We can symbolize this particular statement, compound statement, like R dot P, because dot represents connectives and. Okay, dot represents the connective and. R dot T, this is the symbolization or symbolic representation of the compound proposition. Radhakrishnan is a philosopher and then Rabindranath Tagore is a poet. Again, instead of numerical values, propositional logic deals with truth values. Okay, what is truth value? This is already been discussed in the unit 6. So I think now you know what is truth value. So instead of using numerical values, propositional logic deals with truth values. It is based upon only two truth values, namely the truth and falsity. Okay, truth and falsity are the truth value of a particular proposition. I think you know that so far as the proposition is concerned, it always deals with truth and falsity. But so far as argument is concerned, it deals with validity and invalidity. Because here we are dealing with propositional logic or proposition, so we have to be clear that propositional logic deals with the truth value. Okay, and that there are two truth values, there are truth and falsity, and propositional and therefore propositional logic is a two-valued logic or a bi-valued logic. Two-valued or bi-valued, truth and falsity. Either a proposition or statement can be true or that can be false. Now, so far as propositional logic is concerned, we will find that a propositional logic is based on the notion of truth function. Okay, about truth function also I have already discussed in the previous units, but still I am saying here, so far as propositional logic is concerned, it deals with or it based on the notion of truth function. There are 5 basic truth functions in the propositional logic. What are they? They are negative or contradictory function, conjunctive function, disjunctive function, implicative or conditional function, and the equivalent or the biconditional function. Where we used for negative contradictory function, we use not or we use the curl sign. For conjunctive function, we use the term and its symbol is dot. For disjunctive function, we use the term either or, and we use the symbol well, or it's like English alphabet V. For implicative or conditional function, we use the term if, then, and we use the symbol horseshoe. Again, for equivalent or biconditional function, we use if and only if. We use the term if and only if, and it symbolized is the 3 parallel lines. Okay. Apart from this basic truth function, propositional logic also deals with other truth function. One of them is stroke function. Now, so far as propositional logic is concerned, it deals exclusively to the truth functional compound, and thus non-truth functional compounds do not fall within its scope. It only deals with truth functional compound proposition. Okay. Now, if we'll see propositional logic, it will mainly concern with the different methods called decision procedures to test the validity of argument or argument form, and also to examine whether statement or statement forms are, or the argument or argument forms are, or proposition or propositional forms are tautologous or not. We'll find that all the truth values are T, then it will become tautologous. Otherwise, if there will be both T and F, then we'll call it contingent, and if we'll find only F, then it will call it contradictory. Okay. Now, conjunctive normal form CNF, disjunctive form DNF, and truth. These 3 are the methods which are used in propositional logic. Okay, truth table method, shorter truth table method, and conjunctive function, and conjunctive normal form. Okay. Now, propositional logic adopts a method of proof which is known as formal proof of validity. It is also known as formal derivation, with an aim to establish the validity of an argument. We use truth value to determine whether a proposition is true or false. First, we'll have to convert the argument to a proposition, to a compound proposition, and after that we used to, with the help of truth table method, we used to find the truth value of that particular argument, or the validity or invalidity of that particular argument. But sometimes our arguments become so weak that with the help of truth table method it is not possible to find out the validity or invalidity of that particular argument. That is why, to examine or to verify whether that particular argument is valid or invalid, there is another method, and that method is called formal proof of validity.